Abhishek, do you know other people also registered to this course? Like, since only one
No,
participant
I
is.
don't have any contact with them.
uh, Okay, so let's start. Hi everyone, welcome to this NPTEL course on Combinatorics. I am Prakash Chanjosi, uh, third year PhD student here at ISER Mohali, working in the area of algebraic geometry. So let's start this session. Let me share my screen and start our discussion. Okay. Screen. You can see this combinatorics week 2 problem solving session screen, right?
Yes.
Okay, okay, fine. Okay, so let's start. So let's quickly recall whatever is done in this week. Okay, recall. What is done in this week? How to decrease the size? Okay, fine. Let's look. Okay, so recall what is done in this week. So things done in this week is addition principle. So I will just quickly recall what is this. I'm not going to say in much detail, but I will just speak, not write all these things. So what is addition principle? It says that if suppose A1, A2, A3, these are all disjoint subsets, then it says that cardinality of A1 union A2 union AK is some of their cardinalities. So what is and then second one is subtraction principle. Subtraction principle. This is if B is a subset of a finite set A, then cardinality of A minus B is uh, cardinality of A minus cardinality of B. Then there is a fundamental accounting principle, which is also called product rule, which says that if next decision is independent of the previous one, then the total is the product. Total choices is the product of the choices for each decision. So this is the product rule. Product rule. Fourth one is division principle. And binomial theorem. Uh, binomial theorems. And what else? Northeast lattice path. Lattice paths. Northeast lattice paths. Anything else is done in this week? I guess all these things are done. Nothing more than this, right? So yeah. So let's start our session. These are all the things. I hope you are familiar with these stuff. If not, you can ask me at the problem wherever you don't understand thing. You can interrupt me at any point of the discussion. So let me write the problem, then we start our discussion. Okay. So the first question.
Can you briefly summarize division principle and subtraction principle?
Okay, sure. Okay. Someone is asking for division and subtraction principle. Okay. So okay. So okay, let me color this. Okay. So what is division principle? Suppose you have a function f mapping the set S and T. S and T are any two sets, finite sets, which are of our interest. So when is a function is said to be D to 1, I hope you are familiar with, let me quickly recall. For all, a function is said to be, okay, a function f is said to be D to 1 if for all T belongs to T, there exists D many, there exists D many, say S1, S2, SD belongs to S such that f of si is dl. F of si is t. So then the division principle says that cardinality of t is cardinality of s by t. This is division principle. Okay, so let me add next page how to add this. I am also new to this one. Okay, so this is for typing. This is next page. How to, okay, drag for new page. Okay, fine. Yes. So yeah. So this is division principle which I explained. I hope it is clear. If not, you can ask again. And the next one is what you asked next? Subtraction principle, right?
Subtraction.
Yes. Subtraction one is this thing. Principle. So if cardinality of A is finite, means A is finite set, and B is subset of A, then cardinality of B minus A is cardinality of A minus B, because B is a subset of A. So cardinality of A minus B is cardinality of A minus uh, cardinality of A minus cardinality of, yes. So this is subtraction principle. Yes. Anything else? Any doubt?
Yes.
Another query?
And what about
Okay.
the northeast one?
Okay. So north one is in north. Okay. I will explain. I will do a problem like in class. Okay. So let me quickly just recall the things. Suppose you have in your lecture, professor explained you by saying that this example, right? He started with okay. He started with, let's say you have a matrices a1, a2, and so on and you are taking their product a1 cross a2 cross an. So how many possible ways you can take the product, like this one or this one or this one, all the possible ways. In that way, he explained you how this northeast path can be significant. But basically, the idea is this thing. Suppose you have a lattice. Here you have point P comma Q. Here you have point 0 comma 0. Then number of paths from this point 0 comma 0 to P comma Q and other kind of this kind of problem, northeast paths. So this kind of problem we will tackle. I will do one problem at least of this kind in my session, and one also done in your class. So I hope you have enough idea of how to do this. These are I feel that these are slightly tricky problems. They need yeah. I feel that these are some comparatively difficult than other problems. Okay, so let's start with simple problems. Then we'll go to tougher, which are okay. So first question. So in how many ways can a can a photographer at a wedding arrange 6 people in a row from group of 10 people, including bride and groom, such that both the bride and groom must be together in a picture. Together in the picture. Yes. So this is the problem. Think about this and tell me how to approach, how to do. So this is the question. In how many ways can a photographer at a wedding arrange at a wedding arrange at a wedding? Okay. In how many ways can a photographer at a wedding arrange 6 people in a row from a group of 10 people, including bride and groom, such that both the bride and groom must be together in the picture? So we have total 10 people, and we have to arrange 6 people such that in a row, such that bride and groom are together. Anyone?
So basically, we have to select 4 people out of 8. So this will be 8C4, and
Okay.
but then these 4 themselves can be arranged in factorial 4 number of the ways. So I mean, because the order will matter here in the photograph. So there would
Okay,
be
let me write. Then you will say again. I am writing whatever you are saying. So let's write. So ways, possible ways of selecting, possible ways of selecting 4 people out of 8.
so that
Is
will be
8 choose 4. So then what next?
multiplied by factorial 4 also, because these 4 themselves can be arranged in factorial 4 number of the ways.
Okay. So okay. So he is saying these 4 people can be arranged in a row by 4 factorial ways. So
Yes.
possible rows, possible. What is the question? So possible
Possible ways equal to 8C4 multiplied by factorial 4.
ways is equals to 8 choose 4 into 4 factorial.
Uh,
So
and
what?
and then bride and groom themselves can be arranged in factorial 2 ways.
Yes,
So
into
therefore
2.
the total number of the ways.
Since
Yeah.
bride and groom can be arranged 2 factorial is 2. So there, what is the answer?
So final answer is 8 choose 4 multiplied by factorial 4 and then multiplied by 2.
So what is this?
So this quantity will came out to be, let's see, 4, 6,
8, 5, 6, 7 by 4 factorial and 4 factorial. So both of them will be cut out. Then into 2. So compute this. How much? So 6 5 the 30. Okay. So I should compute it, right? So this is not much difficult. So this is 40. This is
84.
84. I hope you are comfortable. Yes.
Uh,
Then this is 4 4 is 16. Yes. Is this correct?
yeah,
I'm doing some computation mistake or not? 0, 3, 3, 5. Yeah, I hope that's it. No, answer is not correct. We have done some mistake. We have done some mistake.
so
Let me think. We are choosing 4 people out of 8 people, correct? Then, oh no, you are this here. You have incorrect, right? So this is your here. You are incorrect. So let me erase this full page.
Sir,
Yes, yes, yeah. I got it. Where
yeah,
is wrong. I will explain.
yeah.
So his idea is correct, but yeah, it is fine. Yes. So let me explain. So you have ready-madely, you need to select two bride and groom already. So you have remaining four choices. So you select eight, choose four people. So these are fine. So now you have uh, like bride and groom should be both them, bride and groom should be together in picture. So you can take, since let me write and explain you, since bride and groom should be together in picture. So consider them as a one unit, let's say as one unit. So now I can, so you have this five, this you have these four choices and one choice of bride and groom, then I'm taking as a one unit. So for this slot, like, so you can arrange them. So these five slots can be arranged in 5 factorial ways. So 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 these five slots can be arranged in 5 factorial ways, but also we but we also have 2 factorial choices for bride and groom position. So so by product rule, the number of ways, the number of ways, the number of ways in which photographer can take required picture is equals to 8 choose 4 multiplied by 5 factorial multiplied by 2. So compute this. So yes. So yes. So this is 8 into 7 into 6 into 5 into 5 into 2. Right. So what is this? 8 5s are 40, 6 5s are 30, 2 are 60. So this is 8 5s are 40, 6 5s are 30, and then 2 are 60 into 7. 420. This is put together. Yes, this is correct. So this is correct. Any doubt? Any doubt? Or
Yes,
it is clear?
it's
Okay.
clear.
So you got now where you are wrong?
Yes, so basically the bride and the groom, they themselves, apart from, they can appear at different
Yes.
different
You
places.
miss their choices. Like bride and groom can also be rearranged with these four guys.
Yeah.
Yeah, you miss that choice. That is fine. But your approach is correct. Okay, fine. So next question. Mm, question. So count the number of devices of 25 into 36 into 49 to the power 4. Tell me, this is easy. Just one line. Tell me. 25 into 36 into 49 to the power 4. So what is this? Do its prime factorization. So this is 5 square, this is 6 square, this is 7 square ka power 4. So this is 5 square, and so this is 3 square, 2 square, this is 7 to the power 8. So now tell me, I have gave you prime factorization. So what is the number of divisors?
So there would be 2 plus 1 into 2 plus 1 into 2 plus 1. So value came out to be 27 into 9.
Yes. Because 3 into 3 into 3 into 9. So what is this number? 243, right? Yes. Is it clear? Anyone, any doubt? Is it clear?
So I gave the answer by using that formula, but I am not sure the reason.
Yes. Why reason is not clear? What formula use Euler tau function?
So the formula I used was that if a number can be factorized as the product of the prime, say p1 raised to the power a1 into p2 raised to the power a2 and so on, say till pk
Huh?
to the power ak, then the possible number of the positive divisors would be equals to a1 plus 1 into a2 plus 1 and then so
Oh,
on.
so you are saying this Euler tau function, right? So this is the formula. But yeah, how that formula comes basically, you should know this, right? This is not anything much. What are the possible? So any number which will be basically any number will be which will be divisor of this can be will have prime factorization. So it is enough to find the prime factorization, prime numbers which divide this number. So you like numbers which are possible divisors. Okay, let me give you how this will come up. So what are possible divisors basically? See, for first law, you can see that either this number possible divisor can be 5 to the power 0, 5 to the power 1, 5 to the power 2. So for this slot, we have three choices. So that's why I write 3. For 3, we have three choices also: 3 to the power 0, 3 to the power 1, 3 to the power 2. Similarly, for 2, 2 to the power 0, 2 to the power 1, 2 to the power 2. Similarly, for this 7 to the power 8, we have 9 choices, 7 to the power 1. Now, any possible divisor will be like either you can choose one number from here, one number from here. Each of them from one number can be choose anything you can choose, right? Like 5 to the power 0, 3 to the power 0, 2 to the power 0, 7 to the power 0, their product, or 5 to the power 0, 3 to the power 1, 2 to the power 2, anything you can choose. So these are the all possible divisors.
Yes, now I
Have
understand.
you got the idea?
Yes, clear.
Yes.
Yes.
Fine. Anyone else? Anyone else? Any doubt?
No, sir.
Okay, let's go. So this is third one. So this is easy. What is the coefficient of x plus 1 by x to the power 20? So this is what is okay. What is the coefficient of x square in the expansion of our of, tell me, this is easy. You know binomial theorem, na?
Yes, sir.
So tell me, this is easy. So binomial theorem says that x plus y to the power n is summation k is running from 0 to n and choose k, x to the power k, y to the power n minus k. So this is binomial theorem. So you have this x plus 1 upon x to the power 20. So this will be k equal to 0 to n and choose k, x to the power k, y to the power 20 minus k. So you, oh sorry, 1 upon x to the power 20 minus k. 1 by x to the power 20 minus k. So you need, we need x to the power k into 1 by x to the power 20 minus k should be what? Should be equals
2.
x square. Yes.
Yes, x
So
square.
that means what we need?
K
So we
is to
need
be 9.
k is to be
9.
yes. Okay. So that is x to the power 2k minus 20 is x square. So that means 2k is equals to 20 plus 2. So k is 20
Oh,
plus
no,
2, 11.
right.
So that is correct, right? That is also fine. K is 9 is also fine. Yes. So k is 11. So what is your coefficient for this?
So this
So
would be
20 choose 9 or 20 choose k.
20 choose 11. So what is this number? So are you sharp in computation? Just compute it. So what is this number? 20 up to 11 by 9 factorial. So compute it. So it should
It's
come.
a pretty big number. I used a calculator.
Yeah. So it is fine. So it is this number. Compute it whenever you have time. But now, okay, these are easy problems. So at least I feel this one may be a little bit interesting for you. So let's.
I have a query here that so what was the question that what is the coefficient of x raised to the power? So can you show this question again? So the question, what is the coefficient of x square in this? Okay, the next one. Because 20 choose 9 and 20 choose 11, both are correct in this case. Though the value of both the terms is same.
Yes.
But, yeah. So the yes, it's correct. I understood.
Okay. Fine. So question. So find summation k running from 1 to 20 k into 20 choose k. This number. This number we have to compute. So how to do this? Can you tell me how to do this?
I think that we can form that arithmetic geometry series kind of a thing probably.
How?
Like say if we expand this, so it will be 20C1 plus
Okay.
plus 2 into 20C2 plus 3
Fine.
in this.
Right.
Uh,
So what?
so can you write that sequence because I didn't have
Okay, let me write.
yeah. So,
So this will be 1 dot 20 choose 1, then 2 dot 20 choose 2,
yeah,
plus so on, plus
yes,
20 dot 20 choose 2.
yes,
20 choose 20.
yeah. And if I write this same sequence again below with one
Okay.
with one shift. So
How one shift?
so
What do you mean by one shift?
so one shift would be that if I write below this 2 dot 20C2, if I write 1 dot 20C1. So
1 dot 20 P1.
C1. Oh, that won't be okay.
I can't see what is your argument. Can you say again?
So now by using Vandermont's identity, first
What is
and
that?
last,
What is Vandermoon's identity? Can you tell me? Tell me, what is the identity? Am I audible? Hello? Hello? Am I audible?
Yes, sir.
Okay. So suddenly someone stops, so I feel that maybe I get disconnected. Okay, fine. So if no idea, so let me give you a hint. I erase this. I'll give you a hint. So K summation, K is running from. So what is this number denoting? Let's see this. Combinatorially, what is this number capturing? Can you see? Let's say n choose K. Not remove this term. What is this number say? Can you say me? What is this number combinatorially? What is this number capturing? Can you say me?
Uh,
What
we
is
are
it?
choosing
N choose.
we're
Yes.
choosing K things, then for each we have K options.
Yes, you are correct. So suppose we are choosing a suppose n choose K means we are choosing K cardinality subsets of n cardinality set, right?
Yes.
Um, then among these K cardinality subset, we are specifying one set. Among these K cardinality subset, we are choosing one set, right?
Can
Okay,
you repeat?
let me say again. Yes, let me repeat. So I will, okay. N choose K refers for choosing K peoples among choosing refers for possible choices. Let's write in this. For refers for choosing refers for choosing K people. Refers for possible choices of choosing K peoples among N peoples and among these K chosen among the chosen K peoples, if I need to specify one people, then total choices by product rule is equals to A choose K into N choose K. Right? Is this correct or not? Have you got it or not?
Yes.
Correct, no? So, so let me write this claim. Claim K into N choose K. This is same as N into N minus 1 choose K minus. Can you justify me? I gave you enough idea how to approach. Anyone? What is this right hand side capturing? I explained you N choose K. I am choosing first K people among N people. Then I am specifying one people among these K people. So I can do this in opposite way also, right? So among these N people, I can choose one specific people, and then remaining N minus among these N minus 1 people, I choose K minus 1 people. So I have N peoples, right? So these are two possible ways, but both are same. Are you getting or not?
Yes.
Everyone, is it clear or not? Do I need to write? Please unmute yourself and you can speak. That's why I will get some idea whether you are getting or not.
So can you show it by simplifying the expression, like say k into factorial n divided by
That
factorial
will be some arrangement, right? Some rearrangement of terms. You can do that, but I am just explaining you combinatorially. Like this is combinatorics course, so you should be more combinatorial rather than algebraic.
So like say
You-
here in the left hand side,
uh,
so what's the meaning of multiplying this n choose k by the term k?
uh,
Here we have written that among these choices, say
so you have, so you let's fix. You choose k peoples, right? Among n people, you choose k people. Now among these k peoples, you are choosing one specific people. For the choosing this specific people, you have k choices, right? Any one of them can be this people which I am going to choose.
yes,
So
yes,
right.
yes.
So by product rule, this is the choice.
And what is the meaning of the right hand side then? If I choose if I choose k minus 1 people out of n minus
So
1,
yeah.
is
So
that
I'm just
leftover one?
I am just writing this left hand side in another way. So initially I start with n people, I choose k people and specify among these k people one people. So now I'm starting with n people. I am choosing one specific people. Then among these n minus people and one people, I am choosing k minus one people. So this is same thing, right? So I
Yes,
have k people. Yeah.
yes, yes, correct. Yes.
So yeah. So so let me write right hand side as well because RHS also refers for same expression. First we are choosing one specific people person from n peoples and then choosing k minus 1 peoples among n minus 1 peoples. So both are same. So both LHS RHS are same. Right. So what we have to find out? We need to find out this expression, right? So we wanted to find out this expression. Find out summation is running from 0 to 20 k into 20 choose this expression, right? So now how you can write it? You can write it in this way. So now, what is this? So this is what? N is 20, right? N is 20. So take 20 outside because this is independent of this summation running on k. So 20 choose 1, 20 choose 0. Sorry, this is n minus 1. N minus 1 choose k minus 1. So this is n minus 1 choose n minus 1 is 19. So 19 choose minus 1. 19. So 19 choose 0. 19 choose 1. So on, so on, so on, so on. 19 choose. 19 choose. 19 choose k minus 1. So what is this expression? What is this expression?
Subsets of 19 elements.
So what is this?
So 2 to the power 19.
2 to the power 19. So this is 2 to the power 19 into 20. So compute this. What is this? This will be your answer. Is it clear? Is it clear?
Yes.
Okay. So let's do some other problems. Okay. Okay. Question. How many permutation of the set 1, 2, so on, 3n such that are possible such that for any k belongs to 1, 2 up to m up to 3m, k minus ak. How many permutation I should write in this way, right? a1, a2, so on up to a3m. Such that for any k belongs to this, k minus ak is divisible by 3. So this is your question. So question is asking, so how many permutation of this number is possible such that suppose first slot you are choosing any number, second slot you are choosing, then k minus ak. If on kth slot your number is ak, then k minus ak should be divisible by 3, and this ak should be between chosen from this set 1, 2 up to 3m. So how many such possible permutations we have? This is the question. Have you understand the question?
The permutations and the k are from the same set, right?
Yes. So let me write. So your permutation, let's say sigma is of the form a1, a2, so on, a3m. Now this ai's, what are these possible ai's? Ai's belongs to where? 1, 2 up to 3m. Just give us. And the condition is that this I minus ai 3 should divide this I minus a. This is the condition, right? I'm much comfortable with k, so I should write k because this I for some other things. Now tell me, what is this meaning? That means you can simply say 3 divides ak minus k as well. So that means what? Ak minus k is
Remainder is 0, right?
3 alpha for some alpha. Alpha belongs to Z. This implies what? Ak is k plus 3 alpha, right? For alpha is in integer. So what? Now your ak should be from this set. AK should be from this set. AK should be from this set, right? This set. So what are the, suppose k is 1, for k1, what can be possible choices for a1? What are the possible choices for a1? Possible choices for a1.
So the thing is that this should be modulo k mod 3. So 1 mod 3. So the possibilities for A1 would be, it should be congruent to 1 mod 3. So
Yes. So what are these?
1 mod 3 would be what? Let's say it could be It could be 10, it could be, yeah, one more 3, it could be 1, 4, 7, yeah.
Up to what?
Up till, since we have largest quantity is 3m, so therefore 3m minus k. 3m minus 1. Why is it?
Plus
Yes,
1.
3m minus 1, right.
3m minus 1 plus 1.
Yeah.
Now,
Why plus 1? Only because this last quantity is 3m. 3m minus 1. 3m minus 1.
what you are saying?
It should be 3m minus 1. Last term.
3m minus 1, you are saying this?
Yes, this.
But this is bigger than this one, na? This is also there. So this is 3m. Okay. So 3m minus 1. You are saying what? 3m minus 1 is of this form?
Yes, because for, I mean, 3m minus 1 would be one of the possibility for A1. Because 3m, if I add 1 into the 3m minus 1, it becomes perfectly divisible by 3.
You are saying this is divisible by 3?
If I add 1 into it, because this 3m minus 1 is one congruent, is
But-
congruent to the one
But
module.
that is, you are adding 1 to this?
Yes.
But that is 3m, na?
Yes, so that is 3m. So 3m could be,
So this is not in A1, na?
because I can choose any number from 1 to 3m.
Yes.
So since I can choose any number from 1 to 3m, so therefore 3m minus 1 would be one of the possibility for A1.
You are saying 3m minus 1 is the one of the possibility for
A1.
A1.
Yeah.
So if A1 is 3m minus 1,
A1 could be A1 could be 1, could be 4, and
if A1 is 3m minus 1, so let's see. So that means 3m minus 1 is equals to 1 plus 3 alpha for some alpha. So that says that 3m minus 2 is of the form 3 alpha. But this is not correct, na?
yeah, so what should I do? 3m,
These are only possible numbers, right? Because
Yeah.
this should be of this form.
yes, so it would be 3m, 3m minus 2.
Yes.
3m.
Yes, that is what I write, right?
Yes.
Similarly, for k equals to 4 and for k. So by same argument, these are only possible choices for k equals to 4, k equals to 7, so on, up to 3m minus 1 plus 1. Right? Are you getting or not? If you are
Yes.
not getting, I can explain again.
Yes, but then what is the count of these values for k is equal to 1?
What you are saying?
1, 4.
We are saying that what is the possible choices for numbers A1? What are the possible choices for number A2? What are the possible choices for the number A3? What are the possible choices for the number A4? So we determine the possible choices for A1, A4 and numbers of this form. So now we will determine the possible choices for A2 and numbers of this form. Then we will determine number of choices for A3 and numbers of this form. Then we will see how many total possible choices.
Yes.
These are just product of these choices, right?
Yes.
So we already have seen that for these strips of congruent to 1 mod, so AIs which are congruent to 1 mod 3, for these we have exactly m factorial choices, because if first slot you are choosing one choice, then you have remaining what choices? M minus 1 choices among these. These are precisely m choices, right?
So what is the cardinality of this set? How many?
This
One.
set is of m cardinality, right?
What is? What this count is?
Here m is 0, here m is 1, here m is m minus 1. So 0 to m minus 1. Are you getting or not?
Yeah. So So I mean, how many numbers are there? One for the
We have m numbers, na?
yes.
So first lot we have m choices, fourth lot.
Out of 3m number of the possibilities. So how many possibilities have been filtered out for the number?
We have m choices filtered out, right?
Okay. Okay. So for A1 we have m number of the choices.
Yes. Similarly for A4. But we fix the first lot by some number, then A4 we have m minus 1 choices and so on. So possible choices for, so let me write. So possible choices for numbers for AIs, okay, which are where k is congruent to 1 mod 4, 1 mod 3 is equals m factorial. Now similarly for what is for k equals 2. For k equals to 2, by this expression A2 will be of the form 2 plus 3 alpha. Alpha belongs to J. So how this will be? When your alpha, this A2 should be between and belongs to 1, 2 up to 3m. This number A2 belongs to. So what are the possible choices for A2? A2 can be what?
So A2 could be now this time it has to be 2 modulo congruent.
When alpha is 0, then
yes.
A2 is 2.
Yes.
When alpha is 1, then it is
5, 2, 5. And
up to
then
what?
again, the difference of 3 will form a GP and then 3 into m minus 1 plus 2.
3 into m minus 1 plus 2. So this is 3m minus 3 plus 2, 3m plus 1. So
is this count again equals to m?
Yes.
Okay. Okay.
What you are saying?
Yes. Yes. It's okay. That's okay.
It's correct. Yes.
Good.
So
can we use
similarly
the of the arithmetic AP that with this T m minus 1 plus 2 is the last term and a plus nd. So 2 plus and then
okay, you are using this AP formula. You want to use that?
Yes. So that at least I can confirm myself that there would be m number of the elements in this set. Which is
So you want okay, what is that formula? Okay. So that is an is a plus n minus 1 into d, right?
Yes.
So your an is basically 3m minus 1 plus 2. A is 2. And you need to find out. And d is your 3. So what is this term? You can just compute 3m minus 3 plus 2, that is 1.
And should be equals to m. Yeah.
3m minus 1 is equals to 2 plus 3n minus 3. So this is 3m minus 1 is equals to 3n minus 1. So that means you can just see this is m is equals to. Yeah. Have you got it?
Yes.
Yes. So this is just for your sake of convenience. So similarly for so possible choices for AK where K is congruent to 2 mod 4 is equals to these numbers only 2, 5, 7, 2, 5, and 3, then 8, and so on up to 3m minus 1 plus 2 of this form. So this is so possible choices for AK. So total number of choices for K congruent to 2 mod 4 slots is equals to m factorial again. Similarly, for K congruent, sorry, mod 3. Why I'm writing mod 4? Mod 3. Mod 3. Mod 3. Similarly, for K congruent to 0 mod 3, compute total number of choices is equals to, similarly for K congruent to 0 mod 3, total number of choices is m factorial. So total number of required permutation is equals to m factorial into m factorial into m factorial, that is m factorial का whole. So yeah, so is this clear or any doubt you can ask me? Any doubt?
So can you show the final solution?
Yes, this is
So,
any number AK will be either congruent to 0 mod or 1 mod 3 or 2 mod 3. No? So I have done out for all choices.
this, so for k is equal to 0, 1, yeah, so we have factorial of, so y factorial of m number of the choices?
Hmm?
Y factorial of m number of the choices for each value
Okay.
of k?
Okay, let me explain. So we have this one, A1, this is A2, this is A3, this is A4, this is A5, so on, A6, up to so on, A3, right?
Yes.
So for A1, A1 K is equals to 1, so K is congruent to 1 mod 3. So here we have exactly m choices, right?
Yes.
1 to whatever choices we have computed about 1, 4, and all these kind of choices. We have m choices for this lot. But once we are fixing one choice here, then for A4 we have exactly m minus 1 choices, right? Then similarly for A7 we have m minus 2 choices. Similarly, so on. Here we have exactly one choice at last for A3 m minus 1 plus 1 term.
Yes.
Similarly for A2, similarly for A4, these A2 slots, then similarly for A3 slots. So that's why.
For A2 we have m number of choices.
Yes. Then for A5 we have m minus 1 choices, then so on. Similarly for A3 we have m choices, then so on.
Yes, but so how this quantity will came out to be factorial of m then?
So each slot we have m factorial. So first slot we have m for numbers congruent to for AKs where K is congruent to 0 mod 3, we have exactly m factorial choices. For AKs where K is congruent to 1 mod 3, 1 mod 3, we have exactly m factorial choices. For where K is congruent to 2 mod 3, we have exactly m factorial choices. So possible choices for such a sequence, for such a permutation is exactly m factorial into m factorial into m factorial choices by product rule.
Yes. Now I understood. Yeah. Understood.
So others, only one guy is interacting. To others, is it clear or any doubt?
Yes, it's clear.
Okay. So next question. So question. Let me write question like on question. T integers are selected from the integers 1 to up to 1000, in how many ways can these integers in how many ways can these integers be selected such that their sum is divisible by. So yeah, this is the question. Interesting. This is the question. So three integers are selected from 1 to up to 1000. In how many ways can these integers be selected such that their sum is divisible by 3? Similarly, you can do for their difference and other number choices, all that. These are some questions. Let me see the attendance. So I have uploaded there as well. So 4 participants are there. 3 participants. There is something in chat box. Now by vendor modes identify the numbers. Okay, fine. This is the problem. Anyone? Any idea? When three numbers sum will be divisible by 3. Let's start with this. When three numbers sum will be divisible by 3. Three positive integers sum will be divisible by 3. You are familiar with little bit of group theory. Have you done any course on group theory?
No, sir.
No. You are familiar with Z mod 3 group Z3?
Yes. Yes.
Also,
Yeah.
You are not familiar?
Familiar, but how to use that idea of Z3 here? Say if I consider Z and plus modulo 3 as the binary operation, then Z3 will form a group. It's fine.
So
How do
then every element order is divisible by 3, right? So if you are adding any number 3 times, number 1 denote the numbers which are congruent to 1 mod 3. So any number which is congruent to 1 mod 3, if you add it order many times, like its order is divisible by 3. So 3 will be, if you add it 3 times, then it is divisible by 3.
yes, so
So
yes,
so each class is divisible by 3. 1 mod 3, 2 mod 3, 3 mod 3. Anything you choose, if you choose 3 numbers from same class, then they are divisible by 3. But there is one also choice, another choice remaining. What is that choice? Can you see? If you are choosing 1, 2, and 3, then they are also divisible by 3. So such numbers are also like one from each class. There are two possible choices. One can be each 3 number from same class. Another choice is that one number from each class. Anything you do apart from that, their sum will be not divisible by 3.
okay,
So you
okay,
have done.
yes, yes. So yeah, so how
So
many
explain
numbers?
me how we will do now. I have give you enough idea how to do.
So like out of the 1,000 numbers here, there would be 1,000 divided by 3. So that is 1,000 divided by 3.
How many numbers which are congruent to 1 mod 3? 0
So
mod 3, 1 mod 3, 2 mod 3. We have 3 choices now.
yes, so for
Let's
these
say
for
okay.
these
Let, let me write. You will explain. You will tell me. Okay. Okay. Let AI be the set. Okay. Let me write in this way. let AI is equals to AI such that AI is congruent to I mod 3 and AI belongs to where 1 to up to 1000, where I belongs to 0, 1. This is the thing. So this is my set AI. So we have three sets A naught, A1, and A2, right? So I am asking you, what is the cardinality? What is the cardinality of A naught, cardinality of A1, cardinality of, what is this? I'm asking you this thing.
So cardinality of A naught would be equals to 1000 divided by 3.
Okay. So cardinality of A naught is divided by 1000 divided by 3. So this is not divisible by 3. So what is that?
Sir, can I say something?
Yeah, sure.
So I'm not that familiar with group theory, but I've been working
Yeah,
on the
yes.
paper.
I'm,
What I thought is so the we are talking about three classes, right? So in the first class,
yes.
so say one. So you 1 times 333, you have 999, and
Yes.
the last element 1000 will wrap around to the first class, and the
Yes.
remaining of the element two classes will each have 333 elements.
Yes. You are
So
correct.
firstly, we have that one group will form by choosing distinct elements from classes. So each element
Yes.
is from different classes. So we
Okay.
have choices 334 plus 333 plus 333. That's one option.
So you are choosing 1 element from 334, one
Yes,
element from 333,
and
and one
another from
element
the
from
other.
also 333. Yes.
So
Then
this is a valid choice. Then again, we can choose three elements from just one class. So 3343. So 334 choose 3. Yes.
yes.
Yes. So similarly for the remaining two classes.
So you have done everything. So I don't need to do anything now. So this is the answer. So these are the all possible choices. Yes. Any doubt?
So I don't remember exactly, but then there used to be one formula wherein if we want to select k number of the objects from the n number of the total objects, wherein there are p1 number of the objects of the same type, p2 number of the objects of the other type, and say if, and similarly p3, so such that p1 plus p2 plus pk is equal to n, then probably there used to be one formula of the form nck divided by the factorial of p1 multiplied by factorial of p2, and then
What he's saying, I didn't get. Can anyone explain?
so if I want to select k number of the objects from n
Okay.
possibilities,
Okay.
wherein there are p1 number of the objects of the same type, p2 number of the objects of the same type, and say till pk number of the objects, such that p1 plus p2 and so on, say till pk is equal to n. Uh, then in how many different ways can I select k number of the objects? So there used to be a formula for that. Don't exactly
I didn't remember, but even I couldn't understand what you are trying to point
Sir,
out.
I think
So,
what is being I think if I understand, is trying to say the different permutation of n objects where there are n1 indistinguishable, n2 indistinguishable, and so on. So basically
okay.
n factorial by n1 factorial, n2 factorial, and so on.
Yes, yes,
Okay.
yes, yes, yes.
Okay.
So, but that's for ordered objects, right? This is a
That's
set.
for the permutation, okay. Not for the combination.
Yeah, that's for ordered. This does not have any
Okay.
order.
Okay. Fine. Fine. I got what he's saying. Okay. Fine. Yeah. But that is not related here.
Yes.
So let's go ahead. So this problem will take much time. So let's do it at last. And Before this, we will do one more problem. This one. Okay. So question. So yes, this is the question. Give a combinatorial proof of this identity. N factorial minus 1 is same as this thing. Any idea? What is this N factorial is capturing? Unmute yourself and answer. What is this number N factorial?
In factorial is order of n objects, ways to order. But I don't get exactly what is meant by n factorial minus 1. So you are picking out one of the orders, one of the
I am removing one
permutations.
from them. What that is the
Yes.
meaning of subtraction, right?
Yeah,
So N
but
factorial means I have N permutation. I have all possible permutation among N symbols, right?
yes, yes.
Then I am removing one permutation. Then we have exactly N factorial minus one permutation, right?
Yes, I'm asking like in what sense, if in an intuitive sense.
Okay, let me explain. So where is this? Yes. So suppose you are N is equals to 3, let's say. You have all possible 3 permutations. So you exactly know this is the S3 basically. You have identity permutation, 1-2 permutation, 1-3 permutation, 2-3 permutation, 1-2-3 permutation, and 1-3-2 permutation. Right? So I am removing one this is the set basically S. This cardinality of S is N factorial. I am removing one element from this set. Let's say I am choosing T, which is 1-3-2, this permutation. Then T is a subset of S. Then I am saying this cardinality of S minus T is N factorial minus 1. This is what this left hand side is capturing, right?
Yes.
So now think about right hand side. What is the idea you can use? Anyone, any idea? Let's suppose I gave you more hint. We are removing this permutation. Sigma is equals to 1, 2, and 15 common. 1, 2, 3, and this permutation from all possible permutation on n symbols. Right. So cardinality of Sn minus sigma is equals to n factorial minus 1. Now, how this I can rewrite? This is the main thing. I am saying that I can rewrite it as a disjoint union of something, which I am going to explain you. So that this AI is cardinality of exactly right hand side. So how I'm going to write? So this AI is what? AI is
Yeah, is I factorial times I.
I want to explain how the permutation in AI will be look like. So AI will be anything. Okay. So let me write A1 up to AN such that AK is equals to K for K less than n equals to I minus 1, but AI does not equals to I. AI consists of this permutation. So now let me explain why I write in this way. Suppose any permutation in this permutation sigma, one thing is a special thing, right? In on first slot one lies, on second slot two lies, on third slot three lies. So suppose on first slot one does not lie, then this will permutation will if on first slot one is not there, then this permutation is in A1. If in first permutation if it is in first slot I have one, then this permutation lies in something else. That means first slot one. Then in second slot it can have two. It may or may not have two. If it is at two in second slot, then it does not lie in A2. If it has three in third slot, then it does not lie in A3. But if it has three in third slot, if it does not have three in third slot, then it lies in A3. Similarly, up to nth step, if it does not have n in nth slot, uh, if it does not have n in nth slot, it lies in an. But if it has also have n in nth slot, then it also cannot be lie in an. But if it does not have either one in first slot, two in second slot, if it has one in first slot, two in second slot, three in third slot, n is nth slot, so that means this is exactly the permutation sigma. So that is the idea. So have you got or not?
No, sir.
No or yes?
No, sir.
Okay, let me explain. So clearly, what is A1? What is A1? Let's start with A1. What is A1?
It's a single element.
It's a single element. What is that element? Tell me. What is A1? Why A1 is single element you are saying?
No, sir. Confused. Over confused.
I set for k less than I minus 1, where here I is 1, so k less than I minus 1 means k is less than n equals 0. So that is not, does not, there is not this first condition. So AI should be not equals to 1. So on first lot, we should not have 1. So on first lot, A1, A2, so on, AN. On this lot, A1 should not be equals to 1. So for A1, we have what choices? 8 choices, right? For we have n minus 1 choices. We are working with in general n. So we have n choices, n minus 1 choices, since we cannot choose one in this slot. So for now, here we have for A2, we have exactly what choices? N minus 1 choices, then A3, n minus 2 choices, and then an we have 1 choices, right? So how many choices we have? N minus 1 into n minus 1 factorial. Have you got or not? Have you get this? Do you get or not? Tell me, otherwise I will explain again. Have you understood this set AI or not?
Sir, can you explain the set again?
Yes. So in this set AI, so let me explain the set A1. Okay, A1. This is of the form. Here some permutation lies A1, A2, An, where AIs are from 1, 2 up to 2n, 1, 2 up to n. So such that, what is this meaning? So this is saying for I am working with A1, so this means this is saying AK equals to K for K less than I minus 1. Here I minus 1 is 1 minus 1, that is 0. K less than 0 ke liye A0 should be 0. But that is nothing. That is nothing because K is 0 is not the case. K is running from 1 to up to n. So this is not putting any condition. So only condition is this thing. That means A1 does not equals to 1. This is the only condition.
Sir,
So
what
A1
have
should
you written after for k less than equal to I minus 1 then?
and
And
but AI does not. But
acha, but
AI does not equals to. AI
so
does not equals to.
is it not a bit confusing? In the first line, it's AK is equal to K, and then it's but AI not equal to 1.
AK equals to K for where K is lesser than I minus 1, less than n equals.
Oh, okay.
Yes. So that's why this condition is nothing giving here for a K equals to 1 case. So we have only this condition, right? Are you getting or no?
Yes.
No or yes?
Yes.
Yes. So what is the cardinality of A1 now? Now tell me. First slot you
So
cannot choose 1, but
everything
we have
else
remaining
other
n
than
minus 1
1.
choices.
So n
Yes.
minus 1.
And now for A2 up to An, we have exactly n minus 1 factorial choices, right?
Yes.
So we have exactly this many choices, n minus 1 into n minus 1 factorial for this is the required cardinality of A1, right?
Yes.
So now for A2, let's see what happens for A2. A2 is permutation of this form A1, A2, An such that AK equals to K for K less than equals to I minus 1. Here 2 minus 1, that is 1. K less than equals to 1. So only K equals to 1 is the possible case. So that means A1 should be 1 and A2 should not equals to 2. These are the only possible permutation in A2. So now, this is the case. So now what is the cardinality of A2? Now A1 slot is a fix. In A2, we have how many choices? For A2, we have how many choices? N minus 2 choices, right? 1 is already fixed and 2 we cannot put there. So we have n minus 2 choices, right? Since A2 is not 2 and 1 is already put in first slot.
Oh, yes.
So we have n minus 2 choices for this slot. And now for A3, A4 onwards, we have exactly this n minus 2 factorial choices, right?
Yes.
Yes. Now tell me. Now try to generalize. Let me write for A3 also, then we will try to generalize. A1, sorry, A1, A2, An, such that A1, what is this condition meaning? AK equals to K for K less than I minus 1. So I is 3 here. So 3 minus 1, that is 2. AK equals to K for K less than equals to 2. So that means A1 is 1,
Okay.
A2 is 2, but A3 does not equals to 3. So how many such sets?
So A1,
What is
A2
the
is
card?
fixed. A3 is A1 and A2 is fixed, and A3 is n minus 3, and then so on, n minus 3 factor.
Yes. So in general, what is the cardinality of AK? Can you now guess? Suppose you have randomly any given kth slot, AK. So A1, A2 up to AK minus 1 is a fixed, right?
Yes.
For AK, you have how many choices? You
N
cannot put
minus
K.
K.
Yes. In that slot, you cannot put K. So K choices are removed and remaining one you have N minus K factorial choices. So this is precisely N minus K into N minus K factorial choices. Is it clear or not?
Yes, it's clear.
So now can you see these sets are disjoint and all that things? A1, A2. Okay, let me write. Can you see? AKs are disjoint. Can you see?
Yes.
How?
Because every set differs in one position.
Give me some mathematical explanation. Suppose sigma belongs to AJ intersection AK. J does not equals to K. Then what will happen? Some permutation belongs to both AJ and AK. So what will happen? Let's say either J will be lesser than OK. Let's say J is less than K. So what will happen?
So in the
Sigma
AJ,
belongs to AJ implies that AJ sigma is of the form A1, A2 up to AN. This implies AJ does not equals to J. And sigma belongs to AK will implies that A L is equals to L for L lesser than equals to A minus 1. That implies AJ equals to J. So which is not possible, right?
yes.
Since J less than K. J less than K. So these are disjoints. Now we have seen, now can you see any permutation on these n symbols belongs to any sum of AI? If you choose, now I'm claiming this thing. I'm saying Sn minus one permutation, which I removed, 1, 2, up to n. This is precisely A1 disjoint union, A2 disjoint union, A. This is precisely this thing I am saying. Can you see this? Can you see or not?
Can you elaborate the last line again?
I am saying this thing. Sn minus one permutation I am removing from this Sn, which is basically 1, 2 up to n. I am saying this is precisely the any permutation. If I choose from left hand side, this will be in sum of the AI. And it cannot be in two AIs because they are disjoints.
Oh, yes. Get it now.
So how, can you explain me now how to justify this line, this equality? Suppose I
So
choose any sigma from left hand side, how you will show it will be in sum of AIs for right hand side?
Sir, please repeat.
Let's suppose I am choosing any sigma from left hand side of this last line. Then how you need to show that this sigma is belongs to sum of the AI which I have written in right hand side. Then we are done, right? Because this AI is their union is already contained on left hand side. That is clear. Okay, let me write. Clearly, A1 disjoint union A2 disjoint union AN is contained in Sn minus this permutation. Let me rate this permutation as alpha. Sn minus alpha. Right? This side is clear or not? This is not clear on the yes. Please tell me. Unmute yourself.
sir, alpha can be any permutation.
Alpha is fixed permutation. This permutation.
So it can be only this, right? Not any
Yes.
permutation.
No, it has fixed this permutation. I am fixing one permutation, 1, 2, up to n. First slot 1,
Yes.
second slot 2, and a slot n. This permutation I have fixed. Then I am saying this disjoint union is contained in this permutation. This set Sn minus alpha.
Yes, sir. Then because in the union, you can't Aj is not equal to J, but in the permutation, for all J's, Aj is equal to J. So it definitely cannot be in any one of the, but rest of the permutation should be there.
So what side you are saying clear? Which side is clear to you? This containment is clear or not? Which I am written. A1 disjoint union, A2 disjoint union, An is contained in Sn minus alpha. Is this clear or not?
Yes.
How? So let me write. If sigma belongs to here, if sigma belongs to LHS, this implies sigma belongs to AK for some K. This implies what? AK does not equals to K. This implies sigma does not equals to alpha. This implies sigma belongs to Sn minus alpha. Is this clear? Right?
Yes, sir.
So this one is done. Now, what about converse implication? Conversely, Sn minus alpha is contained in Can you explain me how? Right? Sigma is equals to A1 up to En belongs to Sn minus alpha. So what?
So at least there's one Aj that is not equal to J.
Yes. So that means this implies since sigma does not equals to alpha, this implies there exists Aj such that Aj does not equals to J. So what?
So then it will be in one of the AIs. So it will definitely be in AJ, capital AJ.
How?
Because in capital AJ, you cannot have AJ is equal to J.
But
Small
previous
h.
term should be same now. How you are guaranteeing that this Aj minus 1 is J minus 1? How you are guaranteeing Aj? Precisely the Aj should be not equals to J and Aj minus 1 should be J minus 1. Right? Do you understand or not?
So can you repeat what you just said?
In the condition in Aj, the capital Aj, the condition is that Aj minus 1 should be J minus 1 and Aj should be not equals to J, right? But in this permutation sigma, how you will guarantee that Aj minus 1 is J minus 1? You have only get Aj is not equals to J. Are you understanding or not?
Yes.
So tell me, what is your idea? If Aj, let's write Ak is equals to K for K lesser than K less than equals J minus 1. This implies sigma belongs to Aj. If what? If Ak does not equals to K for some K
Then goes to
less
capital
than,
AK.
yeah. So then what? Then what you will do?
Then I can put it in capital AK.
Hmm?
And then I can put it in capital AK. And so inductively there will be some capital A such that it belongs there.
Yes, you are good. That implies what? This
So it must belong to capital AK, or otherwise we can repeat this
K belong to
procedure.
KK, or some AJ, J lesser than K. So by inductive argument, we are done. So yes, so now we have shown this thing. Sn minus alpha is same thing as A1 disjoint union, A2 disjoint union, and now this cardinality we know. This is cardinality of this thing is we know this is basically n factorial minus 1, and we also know by addition principle that if AKs are disjoint sets, then their cardinality is going to be their sum, right? So this is cardinality of A1 plus cardinality of A2 plus cardinality of AN. So this is what this implies n factorial minus 1. This is what is cardinality of A1? N minus 1 dot n minus 1 factorial. A2 is n minus 2 dot n minus 2 factorial plus so on, so on, so on, so on. An is n minus n factorial, that is 0 factorial, and into 0 factor 0. What is n minus 1? That is an minus 1, that is n minus 1, that is 1 into 1 factorial, 1 dot 1 factorial, and then it is 0. So this is the required thing, right?
Yes.
So we are done. Yes. So any doubt, anything in this problem? This is a good problem. Any doubt? No one? Any doubt? Only Abhishek is speaking. Garvita, RK. Any doubts? Or should I proceed? Okay. Fine. This is the interesting problem and it may take some time. So let's discuss. Maybe the discussion may go long. So, question. Okay, so this is the question. Let P and Q be positive integer with P greater than equals Q, then prove that the number of northeast lattice paths from 0, 0 to P, Q that do not go above from the line y plus x is P minus 1 p minus q plus 1 divided by p plus 1 into p plus q choose 2. So in class you have done in the case of p equals to 2 this problem, right?
Yes.
So yeah, so now this is the case. P greater than equals q. So this is how your lattice will be. Is there any rule of thumb? Is there ruler somewhere? Okay. Let me do this. So this is the line p equals to q line, right? This is p equals to q line. And p is greater than q. This is something, some graph like this. Some lattice like this. Here you have 0, 0. Right? This is your q, q. This is your p, q. Right. Now, what is the question asking? Question is asking number of northeast lattice paths from 0, 0 to p, q that do not go above from the line y equals to x. This is where y equals to x line. Right? This is so any idea how to do?
So what this not cost lattice thing is was
This is done in your lectures, one of the lecture, last lecture, I guess. You can look over that lecture. Lattice paths.
Sir, so in the lecture, the our professor did it like, so we don't have n is equal 2n, right? So p, q may be different. So p plus q and then choose p. So that is
Okay.
also standard for all the total paths. So
Oh, yes, that is
once
total
that go
paths.
above the line p, right?
Yes, that.
Yes. So then I need to subtract from that all the paths that do cross the line.
Yes, that
So
go above the line.
so in the
So
lecture,
one thing okay, let me write what you are saying. So total number of lattice paths from 0, 0 to p, q is equals to p plus q choose q, right? Then
yes,
we need to remove the path which goes above the line y equals to x. Yes. So now tell me how you will remove these paths which go y equals to x. How you will count these paths?
so for in each column, there's
Okay.
a first position where the path can cross for the first time. So for in 0, 0, so 0, 1 is the first position where it can cross the line.
Yes, okay. Let's say
So
this is the position.
yeah, so drawing a diagonal from that, so we get all the positions where it can cross for the first time.
Okay.
So we need to subtract all the paths that touch these points.
Okay. So how you will count these paths that touch these points?
So in the first case, so in the for 0, let me think a second.
Use the condition that p is greater than equals to.
So the method that the professor used fails because we have some more additional choices left after to the right of the grid. So the difference of P and Q. That's the pitfall of the method, right?
Okay. What should I do? Tell me, what is your approach? What I do
So
now?
I have
Should I
another
increase the
idea
graded?
actually.
Okay.
So that's different from the combinatorial. So using combinatorial choose in choose k or combinations. So what I noticed is that we can reduce this problem to a recurrence relation.
Okay.
So maybe there's some difficulty finding the closed form of the recurrence relation, but if you notice that, say, if you have PQ, say you want to find how many ways to get to PQ, then that is equals to finding the number of ways to go to P comma Q minus 1 plus the number of
Okay.
ways to go to P minus 1 comma Q for every P
Okay.
greater than Q.
Okay. So you are saying number of ways to go to P comma Q minus 1.
Q is equal to the number of ways to go to P minus 1 comma Q. So P minus 1 comma Q.
Yes, that is correct. That is correct.
So that forms
Yes.
a recurrence relation. But the thing is, we have to find the closed form of it.
Then how it will help to compute us? I can't see right.
So
Right
in
now.
the recurrence solution, you have the base cases. So you can
Okay.
always compute whatever case you want to have.
But how that will help me to compute this y equals to x line, which path goes to above and not? I can't
So
see
you
it
can.
still. Can you tell me again? That is correct. This p comma q minus 1 is p minus 1 comma q. But what next? How you use that? Are you clear or not?
Yes.
Okay. Okay. So let me explain. If you don't have any idea what is my solution, I can explain you it that way. Need to remove the path which goes above the line y equals to x. Fine. So now shift. I'm doing some one-to-one correspondences. That's why I'm shifting. Let gamma be a path which goes above the line y equals to x. So shift the path below by 1 unit. So now shift of gamma is gamma dash, let's say. So what is gamma dash? So gamma dash is the path from here to here, right? This is 0, 0. Here we will have virtually, I should write. Yes, this is the box, not going in direction. Okay. So 0, -1. This is, I'm shifting by 1 unit minus. So this is any path to p, q. So that will be shift by -1 unit. That will be p, q minus. Gamma dash is a path from 0, 0, 0, -1 to p, q minus. It is clearly that paths from 0, 0 to p, q, which crosses line y equals to x, are in 1-to-1 correspondence with paths from 0, -1 to p, q minus 1, which touches or cross the line y equals to x. This is clear? This line, this thing. Is this clear or not? Is this clear? This 1-to-1 correspondence?
Yes.
Everyone, it is clear?
Yes, sir.
Okay. So any such path gamma dash, any such path which will go above the line y equals to x, this will correspond to some path gamma dash of the form which is starting from 0, -1 to p, q minus 1, and at some point it will touch the line, a diagonal line y equals to x. So let's say the path I have chosen gamma dash, then I go to gamma dash, it's 1 unit transform that touches the line y equals to x, first touches or crosses the line y equals to x at the point d, d. Let d, d be the point where gamma dash touches or crosses the line y equals to x. Right? Okay. So then I'm creating some new path. So how I will do that? So this is 0, -1. Now, let's suppose this is somewhere the point d, d. This is the point d, d. So before this path lies below the diagonal. Before this, all the path lies below this line y equals to x. 0, -1 to this d, d. The path lies below the line d, d. So what I can do, I can just reflect the path around this line. This is my line y equals to x line, right? This is y equals to x line. So I can just reflect this path along, and let's say my path gamma is this one. I'm going here, then I'm going here, then I'm going here, then I'm going here, then I'm going here. So this is my path gamma, let's say. Then p, q minus 1 something. Okay, here I'm to cross diagonal or touch the diagonal, at least whatever. So something like this. This is my path, let's say. So now I reflect this. I will say this path. So gamma dash. So I can write in this way, right? So gamma dash is union of the paths. Let's say gamma 1 union gamma 2, where gamma 1 is 0, -1 to d, d, and to d, d, and this gamma 2, where gamma 1 is path from, and gamma 2 is from d, d to p, q minus 1, right? So now what I'm going to do, reflect this first path, but keeping the second path fixed. So what is the idea? Okay, idea is reflect gamma 1 about line y equals to x, and so we will have path gamma 1 prime from 0 -1, 0 to d, d, which lies above y equals to x line up to d, d. Consider the path 0, -1, 0 to p, q minus 1, p, q minus 1, given by this concatenation. But it means they're just their joint. So which is gamma, let's say gamma, what gamma? I shift that gamma prime, then there is star, let's say gamma prime star, that is gamma 1 prime union gamma 2. So this is my gamma. So idea is this thing. So now I am saying that this path which touches the which touches this line y equals to x and goes from 0, -1 to p, q minus 1 are in 1-to-1 correspondence with the paths from -1, 0 to p, q minus 1. And this I know how to compute this path -1, 0 to p, q minus 1. These paths I know to compute. Are you getting my idea or no? So I am talking about this correspondence. Paths from -1, 0, -1 to p, q, p, q minus 1, which touches or crosses line y equals to x are in 1-to-1 correspondence. This is 1-to-1 correspondence. Correspondence with what? Paths from -1, 0, p, q minus 1, where p is greater than q, which crosses this thing, all paths from. What is the key idea here? Any path will cross y equals to x line. Any such path. Any path from -1, 0. So are you clear to this line at least?
Yes.
I will explain you.
Yes.
Any path. How?
Sir, because -1, 0 lies above the line.
-1, 0 lies
above the line. So if you want to,
yes, and we need to go below the line, so somewhere it should cut. right?
Yes.
Because the paths are continuous. So yes. So this will cross the line. So now is this one-to-one correspondence clear or not?
Yes, sir.
How? Anyone can explain me? I have already explained you, but can you just tell me so that I can at least say that you have understand this thing?
No, sir. So each reflection is unique.
Huh. So just reflect this path, that will give you one path. Then if you are given our, then there reflection that will give the path below, right?
Yes.
So we have three one-to-one correspondences. One I already used, which I shift by one unit. Then these two correspondences, right? I have used the three one-to-one correspondences. Correct? First,
Yes.
I've shift by one unit. That is one-to-one correspondence with the path
Yes.
which
Yes.
goes. Then these two correspondences. So I have three
Yes.
correspondences. So what are these paths basically? Let's say this set B. Let's say this set is my B. So what is the cardinality of B? -1, 0 to P, Q -1. What are
So
these paths?
P plus 1 plus Q minus 1. Choose P
Hmm?
plus 1. P plus
What is
1.
what is
P plus 1 plus Q minus 1.
plus Q -1?
Choose
Choose
P plus 1.
Q -1.
Yes.
Yeah, both are. Yes. So that is P plus Q, choose Q -1. So total number of required paths is equals to P plus Q, choose Q minus P plus Q, choose Q -1. So what is this? This is P plus Q factorial by Q factorial into P factorial minus P plus Q factorial by Q -1 factorial into P plus Q minus plus 1. So what is this? P plus Q minus Q plus 1. P plus 1 factorial. So what is this? So take P plus Q factorial outside, denominator P factorial by Q factorial, and this is 1 minus 1 upon, so Q upon, because you multiply Q above and below, that will be P plus 1. So this is the required thing, right? So this is P plus Q, choose Q into P plus 1 minus Q by P plus 1. This is the required thing, right? Yes. So we are done.
Sir,
Any doubt? Yeah.
no, this is clear, but I wanted to ask something. Can you go back to the diagram?
Yes. Yes, this is.
So can we directly find the sum by checking, suppose, so first one is 0, 1. So
Okay.
from 0, 1 to PQ, so we can take any path.
So let's
We-
say this is your 0. Okay, let me understand what you're saying. This is your 0, 1. Now what you are doing?
Yes, so I can take any path from here to PQ. So I know how to count that, all the paths.
Yes, that you know how to count this.
Yes, so along the diagonal, if I do this for same for the all the points and sum it up,
So for all
then
these for all these special point you want to say?
yes.
Okay.
So for each of them, I know what the coordinates are, right? So next
Yes.
point is exactly one more step to the right and one more step to the up.
Yes. 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 Yes.
So is there a nice way to sum it up? I was trying to find a nice way to write it as a summation, but I was not
Yes. Yes. Yes.
sure what
Yes.
the
Yes. You are
parameter should be.
correct. Yes, you are correct. You are correct. Hmm. Among all these diagonal points, it is summation is running. So summation is from. Uh, you are correct. Your idea is correct. It should be doable.
So there's a
One,
kind of a
two.
symmetry also, like you have to
Yes. Yes. I got your idea. This is basically same thing what I am doing. I need to think. Yeah, but the
Sir,
thing is same
so
basically.
let us know if you find something in the next lecture.
Yes, sure. So anything else?
No, sir.
Okay. This is how we stop recording. Stop share. Stop recording. Recording.